Hi, and in today's video I'm going to show you how the period squared of a pendulum is directly proportional to L. Or in the top left you can see t squared is directly proportional to L. So first let's write down our equation for the period of a pendulum, and that is t is equal to 2 pi square root L over g. Now what are these variables and constants? Well, t is period of pendulum. We have L is the length of the string which is attached to the pendulum, and g is acceleration due to gravity. Due to gravity, and this is equal to 9.81 meters per second squared, and remember that this acts downwards. Okay, now we've established what our constants and variables mean. Let's try to prove that t squared is directly proportional to L. So first let's get rid of this square root sign. And how do we do this? Well, we square both sides. So squaring both sides, we have t squared is equal to 2 pi under root L over g, and this is squared as well. Now simplifying, we get t squared is equal to 4 pi squared L over g. Great. Now let's write this over again on a new page. So t squared is equal to 4 pi squared L over g. Now in this equation we have some variables and constants. So what are our constants? Well, it's 4 pi squared and g. Our variables are t squared and L. What does this mean? Well, it means that these can change during our experiment. For example, we can increase the length of our string attached to the pendulum, and this will increase our period, or in this case period squared. So from this we can essentially remove our constants, since they just have a constant effect. They don't change proportionally to anything here. Therefore we simply get t squared is directly proportional to L. Now, what does this mean? Well, if you look here, if we were to draw a graph of this, we have t squared on the y-axis and L on the x-axis. What would our graph look like? Well, as we increase the length of our string attached to the pendulum, t squared increases at a constant rate, so proportionally. So our graph would have a straight line. Likewise, if we were to plot t against L, it would be t is directly proportional to under root L. So if our graph were t and L and under root L, well, it would be a straight line then. Yep, and that's essentially what it means. T squared is directly proportional to L, so as we increase L, t squared increases at a linear rate, hence the straight line. So I hope you all understood, and thank you for watching.